Okay, homework 3, we're going to start by graphing a line given the x and the y-intercept. The x-intercept where it touches the x-axis, which is your horizontal axis, y-intercept where it touches the y-axis or your vertical axis. So if my x-intercept is -2, I would go to -2 on my x-axis. My y-intercept is 5, 1, 2, 3, 4, 5 up, and then I can connect my dots and draw my line. Now on Alex you have the line tool. You don't have to put your 2 dots on there first. You can just use the line tool, click on your x-intercept and your y-intercept, and your line will go through the graph. Number 2 then, graph the line whose y-intercept is -4 and x-intercept is -1. Notice they switched it around to see if I was reading. So my y-intercept is at -4, 1, 2, 3, 4 down, and my x-intercept is -1. Again, I can connect my dots and draw my line. Go ahead and try number 3. So number 3 here, my x-intercept is at +1. My y-intercept is at +3. And again, I have my line. Whoops, if I could draw straight. On Alex, you'll have your line tool. Again, you don't have to mark those 2 points first. You can if you want, but otherwise you can just take your line tool, click on your x-intercept, click on your y-intercept, and the line will be there. All right, number 4, 5, and 6, we are going to write an equation of the line given the y-intercept and a point. Normally in algebra, when they tell you to write the equation of the line, they're going to have you do it in slope-intercept form. Y equals mx plus b. My m is my slope. My b is my y-intercept. Now my slope, just to refresh your memory, is the change in the y direction over the change in the x direction. There is a formula, but they're just going to give you the graph to make you sure you understand slope. So it's easier just to count it out. The top being the up or down, the bottom being right or left. So in this case, if I'm finding my slope, I always like to start on the point on the left and go to the one to the right. To get from this point to this point, I'm going 1, 2 up, 1, 2, 3 to the right. So I have a +2 over a +3. I went up 2, 3 to the right. Again, my slope, if my line is going up as I go from left to right, should be positive. If I'm going down as I go from left to right, it's negative. So I know my slope, the m value, is 2/3. My b is my y-intercept. My y-intercept in this case is a +2. So my equation is going to be y equals my slope 2/3 x plus my y-intercept, so +2. Be careful when you type that in on Alex that the x is behind that fraction, not on the bottom with the 3. So after you put in the 2/3, hit the space bar or click to the back, and so that you get the x behind the fraction, not down on the denominator of that fraction. Number 5, same thing. I want it in the form of y equals mx plus b. My slope is my change in my y over my change in my x. So if I count this one out, again, I'm starting on the left, going to the right. I'm going to go 1, 2 down, and then 1, 2 to the right. So I'm going to have -2 over 2, which is a -1 slope. My y-intercept, where does it cross my y-axis? Right here, 1, 2 down, so my y-intercept is at -2. So y is going to equal -1x minus 2. I don't need the 1 in front of my x, so the better way to write this, y equals negative x minus 2. Also notice that I didn't do plus a negative 2. I'm just going to put minus 2. Previously, when we picked out the y-intercepts, it was just the n number, and the sign goes with that. So we don't want to have plus a negative 2. We're just going to put minus 2 on the end. Y equals negative x minus 2. Go ahead, try number 6 while I'm moving the board here. So on number 6 here, if I'm going to do my slope, starting here, I'm going to go down 1 and to the right, 1, 2, 3, 4. So my slope is going to be negative 1 over 4, or negative 1/4. My y-intercept touches right here at the origin, which is 0. So y equals negative 1/4 x plus 0. But of course, we really don't need the plus 0. So we're just going to say y equals negative 1/4 x for our equation. Seven, 8, and 9, we're going to graph an equation in slope-intercept form. And I'm hoping you have enough experience from college algebra and sort of remember graphing. We're going to graph by using the slope and the y-intercept since that's what we've been talking about. In this case, again, y equals mx plus b, m being my slope, the b being the y-intercept. So in this case, m, my slope is going to be 3, b, my y-intercept is negative 5. What you're going to do is start and plot the y-intercept first. So I'm going to plot negative 5 on my y-axis. I'm then going to use my slope to get to the next point. Since this is a whole number, I'm going to write it over 1. The top number is a positive 3, so I'm going to go up. Remember, the top number is the change in the y direction, so up or down. Bottom number is positive, I'm going to go to the right. The bottom number is the change in the x direction, so left or right, but since it's positive, it's going to go right. So from the point I have marked, my y-intercept is negative 5. I'm going to go up 1, 2, 3, and to the right 1. That's where my next point is going to be. I now can connect my dots and draw my line. So on the slope, top number, change in y, up or down. Bottom number, change in x, left or right. Number 8, again. If my equation's in the form of y equals mx plus b, my m is negative 1/2, my b is 0. We don't have anything on the end, right? Don't have a plus 0, just like on number 6, we didn't have to have the plus 0. So my y-intercept I'm going to mark right away at 0. My slope is negative 1/2. I'm either going to think of it as negative 1 over 2 or positive 1 over negative 2. The negative is either on the top or on the bottom, not both. If I do both directions, if it's negative 1 over 2, I'm going to go down 1 and to the right 2. Down 1 and to the right 2. If I think of it as positive 1 over a negative 2, I'm going to go up 1 and to the left 2. Up 1 and to the left 2. Obviously, you don't have to do both ways. One or the other is fine, but my dots all line up. I can connect my dots and draw my line. So if my slope is negative, the negative either goes on the top or the bottom, not both. Go ahead and do number 9 while I'm moving the board. So number 9, if I'm picking this out, my slope is going to be negative 3, or as I'm going to write it, negative 3 over 1. My y-intercept, my b value is a positive 2. So you marked positive 2 on your y-axis. I'm going to go down 3 and to the right 1. Down 1, 2, 3, to the right 1. I then have my line if I could draw a straight line. Number 10, same kind of thing, but this time they're going to give you the point that my line is going to go through and then have you graph using the slope. So same kind of concept. We're going to start by plotting our point first. Remembering that in my ordered pair, the x direction is first and the y direction is second. So negative 2, 5. I'd go to negative 2 and then up to 5. Negative 2, 5 would be right there. To the left 2, up 5. On my slope, again, I'm going to put it as negative 3 over 1. The slope is in the opposite order as your point. The top number is the change in the y, so the up or down. The bottom number is the change in the x, so the right or the left. So in this case, I'm going to go down 3 since it's negative, and 1 to the right since that's positive. So from this point that I marked, 1, 2, 3 down, 1 to the right. Once I have my 2 points, I can connect my dots and draw my line. So from the point that I plotted, down 3 over 1. Number 11, we're going to graph the line with a slope of negative 3/4 and passing through the point 2, 5. Again, we're going to start by plotting the point 2, 5. So if I start with this one, I'm going to go over 2 and up 5. My slope is negative 3/4. So again, I could do negative 3 over a positive 4, or I could do 3 over negative 4. So if I start negative 3, down 1, 2, 3, and over 4, 1, 2, 3, 4, could have a point there. Or I could have went up 1, 2, 3, and to the left 1, 2, 3, 4, could have a point there. You can see they all line up in a nice straight line. Go ahead, try number 12. So number 12, you started and plotted the point 2, negative 2. So 2 to the right and down 2 is where you're starting. My slope is 1. If my slope is 1, it's 1 over 1. Both of those are positive. I'm going to go up 1 and to the right 1. I could keep going, up 1 and to the right 1. Notice again as I connect my dots from left to right, since my slope is positive, I'm going up. If my slope was negative, I should be going down. 13, 14, and 15, we're classifying variables. They use a little bit different terms than they used in the textbook. Quantitative, quantitative is our number, but instead of qualitative, they're using categorical. So categorical is the same thing as qualitative. Keep in mind, for qualitative or categorical, you have nominal and ordinal. Nominal means there's no order. Ordinal means you can put them in order like good, better, best. If it's quantitative, it's either interval or ratio. Interval says there's no meaningful zero. Ratio says there's a meaningful zero. I like to think of interval as if I can have a negative, where ratios I can't have a negative. Once I hit 0, I'm done. So if I am first of all going to do anxiety rating, highly anxious, moderately anxious, or relaxed, that is categorical or qualitative as what they used in the book. But it's a category, it's not a number. On this one, highly anxious, moderately anxious, or relaxed, I can put those in order. If I was at the doctor's office, highly anxious would be worse than moderately anxious. So this one is ordinal because it does have an order to it. Part B, length in feet of a roll of plastic wrap advertised to be 30 feet long. Well, we got a number there. It's quantitative. So I want to think about plastic wrap. Is there a meaningful zero? Can I have or do I have 0 feet of plastic wrap, or can it be an interval where I have a negative amount of plastic wrap? Well, you can't have negative plastic wrap. It's going to be a ratio. There is a meaningful 0. Once I hit 0, I can't go any lower than that. Temperature in degrees Celsius. Again, if I take the temperature of something, 32 degrees, it's a number, so it's quantitative. Now when I do a temperature, can I have a negative value? Yes, I can. So this is going to be an interval one, because there is not, or the 0 is, how do I want to say this? That 0, there is a 0, but it's not meaningful as far as, is this the total bottom? I can go lower than 0. So I like to think of interval, if I can have a negative, I'm going to have interval. If I can't have a negative, it's going to be a ratio. Number 14 then, if I'm looking at that one, customer satisfaction rating, very satisfied, somewhat satisfied. Again, these are measured in words, it's categorical. Can I put them in order as far as a ranking? Certainly, very satisfied would be better than somewhat satisfied, so it is ordinal. Nominal means there's no ranking. Ordinal, I can rank it. Temperature in degrees Fahrenheit. Again, temperature is going to be measured in degrees. It's a number. 32 degrees. It's quantitative. Can I make a negative? Yes, I can. So it's going to be interval. Closing price in dollars of stock. Closing price in dollars, again, has to do with money. Is it going to cost me $2 or whatever it is? So it's quantitative. Closing price of stock. Am I going to pay for something with negative $2? No, I'm not. 0 is the lowest it's going to be. So ratio, it does have a meaningful 0. Go ahead, try number 15 then. So number 15, total elapsed time in seconds. Time, again, going to be quantitative. Total time for completion of an activity. I'm not going to complete my activity in a negative amount of time. This has a meaningful 0. It is ratio. The name of your cell phone service provider. Name of something is going to be categorical. On this one, the names aren't measured as far as importance. So there's no way to rank them as far as what the name is. So this one is going to be nominal measure of our level of measurement. There's no ranking. It's not good, better, best. It's just the names of the company. Dosage in milligrams of medication. Again, if I'm giving out medication, it's going to be in a number, in milligrams, quantitative. And in this case, again, I'm not going to be able to give a negative amount of medicine, so it's going to be the ratio. There is a meaningful 0. 0 is the lowest amount I can have. And the last 3 on here are discrete versus continuous. Again, discrete, is it a whole number amount? Can I count how many things I have? Continuous, can I have decimal values? If it's continuous on the number line and I'm between 1 and 2, I could have 1.3 in the middle. It's continuous. So, the interest rate charged by a local bank for this quarter for a new home loan. I want to think about, could I have an interest rate as a decimal? Could they charge me 3.2% interest? Well, sure they could. So that one's going to be continuous. The number of damaged chromosomes on a petri dish following irradiation. The number of damaged chromosomes. I'm not going to have a half a damaged chromosome. Either it's damaged or it's not. So it's something I'm going to count. How many of them were damaged it's going to be a discrete number. It's going to be a whole number answer. The number of defective compact discs. Again, I'm counting the number of discs out of 500 that are damaged. It's going to be discrete. The time it takes to drive home from work. So if I'm driving home from work, could I drive for 15.5 minutes? Sure, I could. Might take me between 15 and 16 minutes. It could be the decimal in between, so that's going to be a continuous measurement. So discrete, can I only have a whole number answer? Is it something that can be counted? Continuous, could I have a decimal answer? Is it something that could be between two whole numbers? So number 17, if I'm looking at this one, the number of typographical errors. Again, I would count that. It would be a whole number answer, going to be the discrete. The amount of coffee in a cup dispensed by a coin-operated coffee machine. Doesn't matter how it's dispensed. If I think about my cup of coffee, I might not have exactly 8 ounces. I might have 8.3 ounces, right? I could have a decimal amount in there. The coffee's running and doesn't shut off right away. I might get a little bit extra. So it's not always the whole number. It could be a decimal number. The number of students in a class of 35 who improved their score from the first midterm to the second midterm. Again, I'm talking about a number of students. I'm counting how many improved their score. That has to be a whole number answer. It's discrete. The number of cellular phones owned by a family. Again, I'm counting how many phones. I'm not going to own 3.5 phones. I either own 3 phones or 4 phones or some other whole number. That is a discrete value. Again, go ahead and try the next one there. So on number 18, the time for a participant to identify the color of the letters when the word red is shown in green letters on a computer screen. Ooh, that's a mouthful. But we're thinking about a time. Can my time be written as a decimal? Might it take me 5.6 seconds in order to point something out? Yes, that is going to be continuous. The total number of goals scored. Again, I have the total number. I'm counting how many goals did my top soccer team score. That's going to be discrete. I can't score 2.5 goals. The number of cellular phones. We had this before. The number of phones going to be discrete. It's only as a whole number answer. I own 2 phones. The number of tickets purchased by a caller on the Rose Bowl ticket hotline. Again, I'm looking for a number of tickets. I can't buy 2.5 tickets. It's going to be a whole number, so it's going to be discrete.